This is a quick tour of MechLab 6.5, which is used to control the Gen 6 and other compression systems and load frames from ADC. To connect to the system and access the web interface, all you need is any Google Chrome compatible browser. In this case, we're using the Microsoft Edge browser, which is based off Google Chrome and is included with every current version of Windows, both Windows 10 and Windows 11. We connect our Ethernet cable from our system to the machine, and then we simply type in the address 192.168.127.1, and we have the interface for the machine. I'm connected to a live machine right now, and I've already done some sample testing so that I can take you on a quick tour of the interface. The interface is split into two halves that can actually be adjusted to suit your viewing needs. On the left, we handle information and setup, and on the right, we display and manage data files. On the bottom, we have the footer, which is used for display of the status of the machine, as well as access to manual controls and manual functions. A panic button that we press in case we need an immediate stop or to reset errors. Reset button for resetting the test, and a start button for running the test. You can also run the test by pressing the start button on the front of the machine. The test information pane is displayed when you start up, and it's a tab interface, so you can simply click through different areas of the interface. Test ID defines the name of the test or project that you're working on for the test you're about to do. You'll see that that name is copied over here. So for instance, if I were to change this, the name changes here. This is the name that will be applied to the data when you export these files, if you choose to export the files. Because this is used as a file name, there are limitations to the characters you can enter in this field. You can't click spaces, you can't click weird characters, you can do underscores and numbers, but you can't do something like a $sign or an ampersand. If you're entering a value and you want to undo it, simply press escape or click the cancel button on your field and it goes right back. Specimen name is used to identify the sample you're testing or sample group you're testing. Specimen notes are completely for your use. Use them as needed. The start position defines the start position of the press when you're loading the ball in. So you can adjust this to reduce cycle time, but to still put it in a place that allows you to load the items in as needed. The press load limit is used to protect delicate samples. Right now it's set for the full load of the load cell, but if a sample, for instance, cannot have more than 100 pounds applied to it, or it will be destroyed and can't be tested anymore, you can protect that sample by setting this press load limit, and now no matter what, the press will stop once if that load is exceeded, and the test and the sample will be protected. For golf ball testing, which is what we're going to demo here, the standard load limit is usually fine. The sequence is generated using our Blockly editor. There is a default sequence included with the machine that you can load. You can also wipe out a sequence, make it from scratch. You can use this to copy sequences. You can save changes here. Okay. We identify a sequence by giving it a sequence ID. But when we load a sequence, it inherits the name of that sequence as the ID. Okay. This icon here indicates to us that the sequence has changed and does not match what is in the compression system right now. We click the Upload button, and now the sequence you see matches the sequence in the system. Uploading a sequence or even just a change to a sequence changes the sequence in the controller, the sequence in the compression system, but it does not save that sequence to file. If I were to reload this sequence, it would still be at the original level of 5 there. So using the upload button, you can make changes into your script or sequence without making them permanent. So if you need to make a slight adjustment, that doesn't mean you have to permanently change the sequence. You can also see the Python files that are generated from the sequence. In the future, we will support making direct changes to the Python file, but for now, we're simply showing the code generated from the Blockly editor. File management is done here. If you want to download this sequence, perhaps to share with someone else or just for archival purposes, simply download. And like any other file, it comes in through your browser. You can also delete, and you simply confirm. I'm going to say no here. You can also upload by selecting files from your machine and uploading them into the system. The system can only run and load into the sequence editor files that have been uploaded into it. It cannot run files directly off of the client computer you've connected. So the first step, if you have to load in a sequence, is to upload it in. We have system settings here. You can select units, the metric or imperial. I'm currently running in the imperial, so inches and pounds. In metric, units will be millimeters and newtons. We can configure the data acquisition system. So the system has a maximum sample rate of 20 kilohertz or 20,000 hertz, and typically it will be downsampled to 5,000 or 4,000 hertz. We can also control the hysteresis that is used for determining when we move to load when we hit that level, and that helps control for noise as samples per second increases or there's more noise that could occur in the signal, so we need to use hysteresis as a filter. There's more about hysteresis in the manual. Finally, we can configure the press. These are the live values configured for the load cell, the 500 pounds and the sensitivity. You can set them here by changing these values and then accepting that. We're not going to, same for set sensitivity. Minimum position limit and max position limit are calculated automatically during the calibration routine, where the system calibrates its position using the calibration standard. You can also, if you want to narrow the range of the machine to protect samples or tooling that you've added, you can adjust these. Data, as it comes into the system, is displayed here on the Data tab. You can sort the data by these fields. So this would give you oldest data on top, newest data on bottom. You can also sort if you wanted to know the highest deflection. You can sort by any of these fields that you like. When you're done testing, you can export data. And we can see that data was exported to demo.csv. Data files appear here just like the sequence file manager. And we can download, we can delete. When we need to reset data, we simply come to the toolbar, click the reset button, say yes, and the data is cleared out. Let's go ahead and run the test now. Here's our sequence. This is a standard golf ball sequence. A quick overview. When the sequence starts, it's going to check the sensor value, so read the live value of the load on the press. And if that's greater than 5, it's going to tear that back to 0. We put this in an if statement to save cycle time. We're going to add a scope point so that we record the position at the preload of 1 pound and the position when we're at our crush location of 200 pounds. Notice that our target loads are negative. Compression on a load cell is a negative value. So if we wanted to use the machine for tension, we would be putting in positive numbers. But because we're compressing a golf ball, we want to apply a compression force, we need a negative number. The sign of that number will determine the direction it goes. Then we move to load. We're going to move past our target crush location. We're going to press down until the press, we're going to close the press until we reach minus 210 pounds, at which point it will stop. We define the speed in units per second and an acceleration in units per second. We'll have a brief delay, and then we're going to move back to the start position. This is a new command for Gen 6. Before, you would have to specify a specific position, but now it will simply return to the start position specified here. So as you adjust your start position, your sequence will automatically adapt. Then we'll disable the motor, and we're going to run our calculations for calculating deflection. And then we're going to store that deflection into the data table. I've talked a lot about pounds and positions and speeds. So for instance, this is currently in inches per second and inches per second because I'm in imperial units. The sequence will instead use metric units if metric is selected, but it will not change the sequence data automatically. So the sequence interprets these values in the units that are specified in the settings. We're going to upload into the system, make sure it has the right sequence. We run the sequence by clicking the Start button. We see that it's running. And our test cycle completed successfully. And because I'm sorting on the index column, I'm getting the newer data in the first row, and then subsequent rows will follow after. As an example, we're going to set a press load limit of 100 pounds. Now, our sequence by design is going to minus 200 pounds. So we know for a fact already that we're going to pass this value. Let's see what happens when the press load limit gets exceeded in the middle of a test. And we can see in the middle of the test we stopped, and we get a message that there was an error while moving to load, which helps us understand what's happening. That's a new feature for Gen 6, specific error information for errors that occur during a sequence.